Hey, when using voxels in YAG, it is really important that you understand what you're doing. So in this introduction video, we are going to have a look at what voxels are. This isn't a technical video, of course, so we will remain on a very conceptual level. The goal here is just to give you a few intuitive ideas to help you understand the possibilities and the limitations of this tool in YAG. So voxels are the three-dimensional equivalent of pixels in a picture. In fact, pixel stands for picture element and voxel stands for volume element, but the X is probably inherited from volumetric pixels. So basically a voxel is just a point in space to which we attach properties to describe its color, material, and so on. This is illustrated in this picture, where you can see that pixels and voxels are exactly the same thing in 2D and 3D. So on the left we have familiar pixels on a two-dimensional space, and on the right we have the exact same thing in 3 dimensions, and we just change the name to voxel. So we're going to give a value to the voxels to fill the space the same way we give a value to pixels to color a picture. We generally do this with mathematical functions that are called noises when they are random or irregular, and that assign a value to each point in space. Noises are generally tuned to return values in a limited range. So on this picture, for example, the noise gives values between 0 and 1. 0 is rendered in black and 1 is rendered in white, with all the shades of grays in between. You have to imagine that those patterns are not just applied to the surface of the cube here, they go all the way inside as well. So in this picture we could have, for example, a black voxel here and just underneath it a white voxel, and just then gray voxels all around, and so on. Okay, it's full 3D here. So the way we apply noise in YAG is by generating a noise between -1 and +1, and then we just say voxels with negative values will be visible, so they will look like solid matter, like the solid voxels on this picture, and voxels with positive values will be invisible, so they will look like invisible air between the around matter, okay, like the void voxels on this picture. So when we do that, we obtain a shape corresponding to our noise. Like here, okay? So now that we have a world, I've got a few essential things to tell you. So the first thing is that voxels are the smallest unit in our voxel space, and so they fix the maximum available precision we can get. In YAG, each voxel is about 1 meter wide, which means that it is impossible to get any details smaller than 1 meter. In the exact same way, if we take pixels 1 centimeter wide, we can't have any details smaller than 1 centimeter. It would be just impossible to get the full detailed Mona Lisa on a 20 by 40 picture. All right? So let me show you what this really means in YAG by creating a human pawn here. Okay, that should give you a sense of the scale. Nothing below the size of a cube can be represented in this world. Okay, this precision is very well suited for large terrains, but the price to pay is that we cannot make small or detailed objects like a human-sized chair or stairs. Okay, at this time of this recording, it's not possible to change this precision in YAG, so do not try to sculpt or paint any detail under 1 meter. Okay, the size of a cube. So let's get rid of the pawn and go to the next remark. So the next thing is that there are multiple ways to render voxels, and there are 2 available in YAG. The first and simplest way to do this is what we are seeing here, by assigning a small cube to each voxel. It's easy and helpful to understand how things work, but it doesn't look very natural. So we have a second way to render pixel. It's called the marching cube algorithm. And I won't go into the detail of it, but as you can see, it gives a much smoother and nicer result. Okay, but do not be fooled by the illusion. It is just a better way of rendering cubes, and the 1 meter precision limit remains absolutely the same. All right. The next remark is that of course we do not have to use the noise out of the shelf. We can transform it, apply some parameters to make it more interesting or more like we want. So in YAG we can generate a bunch of different noises here and then transform them, and this is why we have all those parameters here, which I'm not going to explain in this video, but are in essence just transformations applied to the mathematical function that we use as a noise. All right? Finally, the last very important thing to keep in mind before ending this video: computing and remembering the noise for all points in space would take much too much memory and resources, so in practice we work on a limited part of space. In YAG, this part is a cube which will represent the whole available voxel world. We can see the full cube with this preset here. Okay, I'm going to make it 64. Okay, we can change the size of the cube. For example, here I'm going 128. Right? But keep in mind that everything concerning voxels will always happen inside this cube. We have no voxel outside the cube. So in order to illustrate this, I'm going to show you a bit of sculpting here. So you can see that we can sculpt inside the cube. Okay, no problem. But if we try to sculpt anything outside the cube, then we will get holes in the terrain. Okay, so when this happens to your terrain, and believe me, it will happen, remember, this is not a bug. This just means that you have reached the boundaries of your voxel world. All right? Okay, so I think this is all. I hope that by now you're starting to understand a bit of the principles that work behind the scenes when you are creating a terrain and the limits that comes with this technology. Okay, so I'll stop the video here. I hope it was interesting, and if it was, then hopefully see you in the next. Thank you, bye.